Alright, so in this problem, I have 9 to the power of x plus 12 to the power of x is equal to 16 to the power of x. So what I'm going to do is first start by dividing both sides by 9 to the power of x. So this means that I get 9 to the power of x over 9 to the power of x plus 12 to the power of x over 9 to the power of x is equal to 16 to the power of x over 9 to the power of x. Now, 9 to the power of x over 9 to the power of x, those two cancel out, and I get 1. So I have 1 plus 12 to the power of x over 9 to the power of x is equal to 16 to the power of x over 9 to the power of x. Now, from here, I can rewrite this as 12 over 9 to the power of x, and 16 to the power of x over 9 to the power of x, I can rewrite this as 16 over 9 to the power of x. Now 12 over 9, that simplifies to 4 over 3. And 16 over 9, that simplifies to 4 squared over 3 squared. Now 4 squared over 3 squared, that's the same thing as 4 over 3 squared. And now I have this to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 4 over 3 to the power of 2 to the power of x, I can rewrite that as 4 over 3 to the power of x to the power of 2. And now I'm going to let 4 over 3 to the power of x equal to the variable u. So if I substitute in u for 4 over 3 to the power of x, I get 1 plus u is equal to u squared. And now if I subtract u and 1 on both sides, these two cancel out, and I get u squared minus u minus 1 is equal to 0. Now, to solve this equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get u is equal to negative of negative 1 plus or minus the square root of b squared negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1. And this is equal to positive 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So we have u is equal to 1 plus or minus the square root of 5 over 2. Now, remember how we let 4 over 3 to the power of x equal to u. Well, this means that 4 over 3 to the power of x is equal to 1 plus or minus the square root of 5 over 2. Now, this gives me two equations. I get 4 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. And I get 4 over 3 to the power of x is equal to 1 minus the square root of 5 over 2. Now 1 minus the square root of 5, that's going to be a negative number. And notice how this is a positive number to some power. Well, you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation, and all that's left is this equation. So to solve this equation, what I'm going to do is start by taking the log on both sides. So I get log 4 over 3 to the power of x is equal to log 1 plus the square root of 5 over 2. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. In this case, I have log 4 over 3 to the power of x, and I can move x to the front. So I get x times log 4 over 3 is equal to log 1 plus the square root of 5 over 2. So now that x is a term, we can isolate it by dividing both sides by log 4 over 3. So when these two cancel out, and I get x is equal to log 1 plus the square root of 5 over 2 over log 4 over 3. And log 4 over 3, I can rewrite that as log 4 minus log 3. Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So I want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation. So x to the power of x is equal to x to the power of 2. And now I'm going to divide both sides by x to the power of 2. So if I divide both sides by x to the power of 2, I get x to the power of x over x to the power of 2 is equal to x to the power of 2 over x to the power of 2. And x over x to the power of 2 over x to the power of 2, these two cancel out, and I get 1. So I get x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So x to the power of x over x to the power of 2, that's the same thing as x to the power of x minus 2, which is equal to 1. Now, I'm going to take the natural log or ln on both sides. So I get ln x to the power of x minus 2 is equal to ln 1. So if I have something in the form ln a to the power of b, I can move this exponent and b to the front. So it's going to equal b times ln a. So in this case, I have ln x to the power of x minus 2, and I can move this to the front. So I get x minus 2 times ln x is equal to ln 1. Now I can distribute the ln x. So I get x times ln x minus 2 times ln x is equal to ln 1. And ln 1, that's equal to 0. ln 1 equals 0. So now I get x times ln x minus 2 times ln x is equal to 0. Now, I'm going to go back and factor out ln x. So I get ln x times x minus 2 is equal to 0. And now I get two equations. I get ln x is equal to 0, and I also get x minus 2 is equal to 0. So for ln x equals 0, we already know that ln of 1 is 0, right? So x equals 1. That's one solution of x. And for x minus 2 equals 0, that's simple. All we have to do is add 2 on both sides. And I get x is equal to 2. So x equals 1 and x equals 2 is my solutions. Now, going back to the original equation, we have x to the power of x equals x to the power of 2. So to check, I'm going to first start by plugging in x equals 1. So if I plug in x equals 1, I get 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is also 1. So this is right. Now if I plug in x for 2, I get 2 to the power of 2 is equal to 2 to the power of 2. And 2 to the power of 2 is 4, 2 to the power of 2 is 4, so this is right as well. meaning my two solutions are right.